And this is again the ds-incubator about exploring data with the tidyverse. We are in the previous last session of this series and of the year. Hopefully today we'll cover all that I was planning to cover, and next time hopefully the same. So with that we could end the year with this series, and then next year we can start with something else. So the goal today is to cover the covariation between two categorical variables, and then also between two continuous variables. Last time we did it between one categorical variable and one continuous variable. So this is the last section, the last part of the section about covariation. So the specific objectives are going to be, well, exploring the covariation between two categorical variables to begin with, but then there is some nuance to how you can do things. So we're going to be learning how to explore that covariation through counting observations, but then mapping them in two different ways. One using area as one way to understand the amount of observations of one variable versus the other. And then also we're going to be doing it with color fill. Then when it comes to exploring the covariation between two continuous variables, there is also a few little things that we're going to be doing. One issue that we're going to face quickly is the idea of overplotting, where a lot of points fall on top of each other and then the patterns are not so easy to see. So we're going to try solve that overplotting problem with two approaches. One is using transparency and the other one using bins. We're going to be using two kinds of bins, by the way. And then we're going to be using a strategy by which we transform a continuous variable into a categorical variable, which we did last time or previous last time, but then using a box plot to explore the relationship between those two continuous variables. So the trick is, in this particular case, if the box plot is a good way to explore these two continuous variables, then is to make one discrete, one make it categorical, and then explore it using the techniques that we learned last time. And then we're going to be also learning a trick to map the width of the box plot to the number of observations that we have for each category. So let's jump to our studio. Today I'm going to be working with this degraded code to slow myself down a little bit and to make the session a little bit more, give it a feel of a live session. So of a live coding session. So the first thing we're going to be doing, as usual, is attaching the tidyverse package that comes with a bunch of packages, including the two that are the star of this series, which is the dplyr for example, doing things like counting or selecting variables or filtering rows. And also the package ggplot2, which is the star of the show, really, because it's what is allowing us to visually explore those relationships. So the very first section is the two categorical variables. And for that, we're going to be focusing on these two columns from the dataset diamonds, color and cat. Color is self-explanatory, it's just the color, but it has an order, and the D color is the best and the J color is the worst. And then we're going to be also using the cat variable, which encodes the quality of the diamonds, and it is also an ordered variable that goes from fair all the way to ideal. So just as a little refresher, if we want to select those two variables only, we would use the verb select from dplyr. So we take the diamonds data set, and then we select the variables that we just discussed. So we select color, in this case it's spelled like this, and cat. So we run that, and here at the bottom we can see that we have these two variables, and they have values like E, I, J, or ideal, premium, good, which means that they are categorical. So there is an order in them, and we're going to be exploring it in a bit. So the first thing we can do is use geom count, which automatically maps the amount of the number of observations to the area of points. So let's see how that works. So as a little refresher of ggplot2, remember we always call ggplot with the dataset first. Last time we started using this abbreviated form where instead of saying data equals diamond, we just say diamonds. And hopefully today we're gonna see a bit more of the value of being so succinct, so that we highlight the arguments that are more interesting. So we are gonna take here the diamonds data set and wrap it here in ggplot2, which is the way we always start a ggplot. And we're gonna be using this very cool function geom_count, which takes, as usual, an aesthetic representation of the data that needs to be mapped. So we're gonna be using the two variables that we are working with today, color and cut. So if we do that, what we get here is this x. Let me move this a little bit to the left. So we have this x axis where we have the color as we specify. So this is an implicit way of saying x equals color, but we omit that because it's always the first argument to the AES function. And then on the y-axis, the cat, so which is the same thing that's saying y equals cat. But again, because x and y are always first and second argument to the call to AES, we just omit it so that if there is any new argument, that one is going to be kind of highlighted. So in this case, what we see is that the number of observations for example, the intersection between fair and D is not so great compared to, for example, ideal and D. So the covariation here is observed as like a specific pattern in specific values of the X and the Y axes. So here we do see some pattern here where we have more, like you have bigger areas, so bigger points here towards the top left. So that suggests that this relationship between the cut as you go from fair to ideal, it gets we have more ideal diamonds on that have a color say J, F, and D that we have from I and J, right? So this instead of all bigger and smaller points being all mixed, we see some pattern there, and that is what it's telling us about that covariation. So that's not the only way we can represent that covariation between two categorical variables. One really nice way is to use, instead of area, use color fill, because our eyes as humans are not all that good at comparing areas. Apparently they're a little better at comparing colors. So what I'm gonna be doing here is I'm gonna count first manually using dplyr the number of observations in the color and cut columns. So let me highlight just this code to see what it prints. So I'm doing a little bit what ggplot does internally. I'm doing it now by hand. So I'm taking the diamonds data set, and then I'm counting the number of observations by color and cut. So what we get is a new column called N, right? And that is the one that tells us how many observations we have of, for example, fair diamonds of color D. And if we go back to the plot that we plotted before, we could see that, for example, fair diamonds of color D is a relatively small number compared to, say, ideal of color D. So that is confirmed here too, right? So ideal diamonds of color D are in close to 3,000 observations. That's why the area here is bigger. But now that we have that N, that's what we care about, we can use a different function, not geom_count, but instead geom_tile, that takes, again, color in the x-axis. We're going to map cut to the y-axis, but now we use a third dimension. Before, when we used geom_count, the third dimension was automatically the area of the point. But now we are using geom_tile, and we already have created that variable n that allows us to map it to the n, so to map it to the fill color of a plot, of a tile plot. So I'm going to say here n, right, to map the third dimension to this third variable that we created before. So note that here I'm going from a pipe, right? That is what we use for, just about any package in the tidyverse. But now I'm going to, once we have done that, created that data set, then we feed that data set to ggplot. But then once we are in the ggplot world, then we combine things with a plus symbol, no longer with a pipe. So I clarify that because that's a very common mistake. And the reason why there is two different ways of composing things is just historical. So ggplot2 package was created before the tidyverse existed. The pipe wasn't conceived at the time. It became very popular later, but by the time the pipe appeared in the show, ggplot2 was already used by so many people that was, it just is what it is. So we just need to remember to move from the pipe to the plus symbol to combine things here. So this is the kind of plot that we get. You can see, darker colors, in this area, similar to what we saw before. That pattern of specific areas having more observations. The same thing we see here, which is fair enough because it's the same plot. Okay, so now we are gonna move to two continuous variables. But maybe before I do that, we could intermingle a section of questions or comments if you do have some. So I'm gonna go back to your faces here and prompt you to ask questions or make comments if you have them. Nothing now. Okay, this was fairly brief. So what we just achieved is exploring two categorical variables. We used the very magic function geom_count from ggplot2 that does everything itself. It counts the observations and represents them as changes in the area of points. And then the second thing we did is we counted things manually with dplyr, with the function count, and then we passed that to a different function of ggplot2, which was geom_tile. And we used the mapping fill to represent that third variable, the n, so the number of observations. So now we move on to two continuous variables as opposed to two categorical variables. And now the columns that we're going to be exploring is carat, which is the weight of the diamond, and price. So it's quite intuitive, right, to think that bigger diamonds weight more and are more expensive. So we do expect a strong covariation between their weight and the price. So let's do a little select to just have a quick look at carat and price. What we want to see is confirm that these two columns here are numbers. So more specifically, carat is a double. That means that it can take fractions of a number, and price is an integer, meaning that it just takes round numbers. But it looks just because the price was set that way, and there is no reason why the price has to be an integer and could not be continuous. So we would take these two as just continuous variables anyway. So the first thing you would do generally when you want to explore the covariation between two continuous variables is to use a scatter plot. And remember that in ggplot2, a scatter plot you achieve with the function geom_point. So as we did before, we do a ggplot diamonds to pass that data set to the plot, and then we call the geom_point with the X and Y's columns mapped to carat and price. So if we run that, I'm pressing Ctrl Alt and C to run this specific chunk, we see that scatter plot, and we see that strong relationship between higher numbers of carat also have higher prices, right? So that covariation is very clear. It is what we expected. But one thing we know too is that the points here in this section overlap with each other. So any pattern that might be in there is totally hidden by the overlapping. So we need to fix that. So when we have very, very big data sets, scatter plots become problematic. So one way in which it's common to start trying to solve the problem with transparency. So if we made the points, say, a 10% transparent as opposed to 100% transparent, which is the default, then we would probably get a little more insight into what's going on in here. So let's do that. The argument that does that is alpha. So know how alpha is outside a call to AES. So AES is something that we map to data. Alpha is something that we fix in the plot. So we're gonna use for every single point the exact same transparency, just 1/10 of the opacity that the full opacity that it could have. So with that, we see now, the pattern is kind of a little clearer, but still, when you have a lot of data, sometimes not even that, cuts it. Not even that, gets you what you want. So we're going to be exploring a couple of other strategies. We're going to be using, instead of points, instead of a scatter plot, we're going to be using also the color density. The color density in bins. We're going to be using bins in 2 dimensions. Before, when we used box plots, we were, creating. Transforming a continuous variable into a categorical variable in bins that had only 1 dimension. So now we're going to be doing it in 2 dimensions. And also we're going to be working with these a little smaller data sets that takes only the rows where carat is smaller than 3. I think that in the book they did that not because the data set becomes really smaller, only 40 observations are actually lost with that filter, but I think it is because, remember last time we were working with some outliers and missing values and stuff like that. So I think that with this filter, what we do is we get rid of those problems that would probably distract us from the patterns and things that we want to explore today. So I think from now on we're going to be using this smaller data set. Okay, I acknowledge that we are 20 past. I'm aware of that, so maybe Jacob remind me in 5 minutes again, because we still have a bit to cover here, and I don't think we have accumulated enough questions or comments. Thanks. So there is a very interesting function in ggplot2 that is called geom bin 2D. So these two are the same thing. I tried it, compare them with identical, and they are identical. So let's use this one because it's the one that is documented in the help file, and the other one is just an alias. So this is the new geometric representation. Apart from that, nothing really changed. So if you see the plot that we used before, it was also like a call to geom point with the aesthetics mapped to carat and price for X and Y. So we do the same thing now. Now we're not going to be using the alpha argument because the representation itself is different and allows us to see the number of observations in a different way. So this kind of helps with overplotting a little bit. So we don't need AES. As you can see now, what before was where we see a lot of observations, we see darker colors, right? And where we see less observations, where we see a lot of observations, we see lighter colors. In this case, like lighter blue means 6,000 observations around here, and the darker ones are a few fewer observations. So that's one way to solve the overplotting problem, and it looks quite pretty, by the way. There is another flavor of it, same thing, but now the function is called geom hex, and what it does is the same thing, but now with hexagons as opposed to squares, which is really nice too. Same thing. Now we can even see holes in the data set where there is no observations. That's another way in which we can solve overplotting. So know that for that function geom hex to work, you need to install the hex bin package. You can do that with install.packages. If you don't have it, the plot will be kind of empty, and I'm pretty sure you will get some kind of message. And now there is something else we could do as well. Now we move to that part where we create a discrete variable, so a categorical variable out of a continuous variable. So I'm going to do this by hand first to show you pretty much what's going on, and then I'm going to show you a call to a very magic function from the ggplot2 package. But I think that seeing how this breaks down can help understand what we are trying to achieve here. So we start with the smaller data set. It is just a data set with a bunch of columns and a bunch of rows. What I'm going to do is I'm going to use the function mutate from dplyr to add a new column. I'm going to call it carat2, which is is based on carat, but now we're going to make a discrete version of it. So we're going to cut that continuous variables in bins that are as wide as 0.1 in the scale of that variable. So that's the first thing we do. So we mutate the data set and add that new column called carat2. But because here we print too many columns, it's kind of hard to see. So I wanted to show what we achieved by zooming into the data set, specifically selecting here in line 2 to 5, selecting the columns price, carat, and carat2. So the interesting thing here is to compare, what carat was before. It was just, a real number, 0.23, for example, falls into a specific bin, 0.15 to 0.25. And the same thing happens for these three observations. So what we are doing now is grouping continuous observations into bins that are discrete, right? So that's what we are achieving. Also, for clarity, I added a call here to arrange to see the data set in a specific order, in the descending order of carat. Also to show, that, how different bins, in this case, there is a bin here that contains 3 observations, and then there is a bin here that contains a lot more. So that's what we achieved. We are converting this carat variable that was continuous into a discrete variable that is carat2. So now we do have that carat2 variable. Thank you. 5 more minutes. Hopefully we're gonna get there. Now we have that carat2 variable, and what we can do is, instead of plotting carat, so actually let's do that like this. So if I do, the data set is different, but I could plot carat just as S and get the plot that is not what we want. But now if we plot that, because there is no grouping there, so all the variables, all the values go in one bin. But if we use the carat2 that has different bins, because we just created it, then this is what we get. So this is closer to what ggplot2 could give you. It could give you actually something that is a little nicer. So the way you do that with ggplot2 directly is directly with a new argument called group. So if you, here we're using not only the X and the Y arguments to the AES function, but also we are telling how to group the data. And we are gonna be grouping it in the same way that we created the carat2 variable before. So here we are inside the ggplot2, the geonboxplot call, we are grouping the carat variable. So we are saying not only what goes to the x-axis, what goes to the y-axis, but also how to group the values. So this is now same thing, except that the axis x is a little nicer. And just to refresh, what the world would look like if we don't use any grouping whatsoever, what we saw before. If we don't group data, what you get is just a single box. That's not what we want. We want something like this. Right. So now I'm very close to the end, so I'm gonna go fast here. We're gonna try recover information about, okay, how many observations do we have in each of these bins? We see, we have a sense for the spread in price, but we don't have a sense for how many observations are represented in each of those boxes. So we can do that with the bar width argument to ggplot. So if you say, so the default is of course false, which intuitively you would know. So that gives us the same plot that we had before. But if we say true, then we have a different story. So now we have very thin boxes for bins that have very few observations, and wider boxes for bins that have more observations. But that's still not maybe kind of clear enough. There is another alternative we can use, and is to do the same that we did before, but instead of using the cat width, we're gonna use the function cat number. And now what we are doing is we are forcing each box to have the exact same number of observations, but then that box may spread over different values of carat. So the result of that is that you have bins like this. So this box has about 20 observations, same as this one and same as this one, but the spread horizontally in carat here is a lot bigger than here. So and now we can see a relationship between carat and price that is a lot more clear than it was before. Before we couldn't see that, and now we see that as the boxes go to the right and to the top, they become bigger. So that's the covariation that we wanted to explore. So with that, we covered everything I wanted to show today, with very little time for questions and comments, but hopefully that will get us somewhere useful. So go ahead if you have any question or comment to add.
Nothing from me. Thank you, Mauro.
Thanks very much. With this, we finish covariation. There is only one more thing we're going to be covering next week, which is the idea of models and how to extract patterns. And then we're going to take a break for the holidays and then come back next year with a new series that we're going to be voting through Slack. Thanks, everyone. See you next time.
Thank you. Bye-bye.
Bye.